Okay, so actually there was some network issues. That's why I got disconnected. Let's see again. So I hope you now understand that how the variation of acceleration due to gravity occurs. Here, as per the height, if you see observe as per the height, the acceleration due to gravity, it varies as 1 minus 2h by r. Whereas in the case of acceleration due to gravity with depth, it varies as g times of 1 minus d by r. So in both the case, the acceleration due to gravity decreases. So you have statement 1 is incorrect. So statement 1 is correct. This statement is correct. It states that the Earth's gravity decreases as you go up and down from the Earth's surface. So in both the cases, acceleration due to gravity decreases. Now the second one said acceleration due to Earth's gravity is same at a height h and at a depth d from Earth's surface if h is equal to d. So the answer is no. As you can see, this varies as per the height. As per the height, g dash varies as g times of 1 minus 2h by r, whereas here it varies as g times of 1 minus d by r. So there is a difference. It cannot be both the places. It will be equal only if d is equal to 2h. So at a place, if d is equal to 2h, then the acceleration due to gravity will be equal and not when d is equal to h. Okay. So the statement 2 is false. And hence we can choose out of the given statement that which statement will be correct and which statement will be false. So here, yeah, gravitation. So you have statement 1 is incorrect. This one is false. So both the correct answer is 3. Statement 1 is correct, but statement 2 is incorrect. I hope you got all of you.
Yes, sir.
Yeah. So let's see the next one. If the distance of Earth from Sun is 1.5 times 10 to the power 6 kilometer, then the distance of an imaginary planet from the Sun, if its period of revolution is 2.83 years, what would its distance be? Okay. So how we are going to predict this distance? Clearly, as you can see, here only two things are given to you. This is the time that is taken for revolution by the imaginary planet. This is the distance of Earth from the imaginary planet. So this is the distance of Earth, RE, from the Sun, and this one is your time. So which concept is to be utilized here? Can you recall which concepts to be utilized? Okay. Okay. What is the time period of revolution on Earth? Yes. What is the time period of revolution on Earth? On Earth, we consider the time period to be 1 year, and with our 1 year, so time period on Earth, we take to be 1 year. This is 1 year on Earth. Okay. And we know the distance of Earth from the Sun. So distance of Earth from the Sun, we mark it as RE, distance of Earth, given as 1.5 times 10 to the power 6 kilometer. And you can convert it to meter, which will be 1.5 times 10 to the power 9 meter. However, there is no requirement for conversion. We will see it. Then the time period of revolution of the other planet is given. The distance of imaginary planet from Sun, if its period of revolution is given. So its period of revolution for the Earth, the period of revolution is 1 year, and the period of revolution for the imaginary planet is given as 2.83. Okay, so which concept is relating all of them? I want to find out the distance of the imaginary planet. This is what I have to find out. Okay. Can you recall the Kepler's laws of motion? Which Kepler laws of motion unites all these? Which Kepler's laws of motion unites radius and time period? That means distance and time period. Don't we have t square proportional to r cube? Do we have this t square proportional to r cube? So we have this t square proportional to r cube, and hence we can utilize it. So t square for earth, arc of earth. If you have t square for imaginary planet and r square for the imaginary planet, they should all be proportional to each other. And hence, if you divide them, so here you can obtain the answer. By dividing, the constants will get cancelled, and you will have here Te over Ti whole square should be equals to Re over Ri whole square. Now, just by putting the value, we can get the answer. So, what's the answer that we are getting? What's the answer we are expecting here? Te, the time period on Earth is 1 year. So we have 1 over time period of imaginary planet is that 2.83 whole squared should be equals to radius of the imaginary planet, radius of Earth. So that not the radius, distance of the Earth from the Sun, that is 1.5 multiply 10 to the power 9 over Ri, that is what we have to find out. And this is cube. Okay. So this expression can be solved easily. Can you solve it out and see which one is the correct answer? So for this, you need to find the square of, rearrange the terms. You get Ri cube will be equal to 1.5 multiply 10 to the power 9 cube, and this whole multiplied by 2.83 squared. So now this should be the distance. So okay. Yes. So if you find out the cube root of it also, if you take Ri directly, so Ri would be equal to, you can find 10 to the power 9. Here you will get meter, and you will have 1.5 cube multiply 2.83 squared, and then whole 1 by 3. So 1 by 3, you will get 1.5 multiply 2.83 squared, 2 by 3. So this is multiplied with 10 to the power 9 meter. And if you convert to kilometer, so it would convert to 10.7. So you will get 10 to the power 6 kilometers. Now you need to just find out this, find the square, and then find its cube root. So square of 2.8 and then find its cube root. You will get the answer here. Okay. So what answer should be there? Can you guess the answer without just going into complex calculations? Can you guess the answer?
Option 3.
Option, yes, it is certainly option 3. Okay. As if you multiply, you will not get 6, you will be getting near about 3. And 3 times 10 to the power 6, you have already got. So it's option 3. Got it? So it's not necessary every time to perform the complete calculation. You can take an approx value here. Given below are two statements. One is labeled as assertion and other is region. Okay. So the value of g, acceleration due to gravity, is less at Mount Everest than its value on surface of Earth. In the light of the above statement, choose the most appropriate. Okay, assertion is a pendulum clock when taken to Mount Everest becomes fast. And the reason says the value of g is less at Mount Everest than its value on the surface of the Earth. Okay, so what I teach students to solve this is that first you find out whether assertion is correct or not. So what can you say about the assertion? Is the assertion correct? A pendulum clock when taken to Mount Everest becomes fast. So we know here that the time period is given by 2 pi under root L by G. Okay. So what will happen to the pendulum when it is taken to the Mount Everest? So the value of G will change, as we know when we move up, when we move at a certain height from the Earth's surface. So acceleration due to gravity decreases with G dash equals to G times of 1 plus h by r whole squared minus 2. So this is how the value of G dash decreases with G. G dash equal to G times of 1 plus h by r minus 2. Now, how it decreases like this? So, of course, at Mount Everest, the value of G will be less as compared with the surface, as compared with the ground surface. Okay, so it becomes fast. What about the time period? If I say I have time period on the Earth's surface and I have time period on the Mount Everest, so which one should be greater? I have G and G dash. So G is greater than G dash. What can we say about the time period? Since time period is inversely proportional to this, so time period on the Everest will be greater than the time period on the surface of Earth. You can see here the time period is inversely proportional to acceleration due to gravity. So time period will be greater on the Everest. Hence, the pendulum will not move fast. It will become slow. So I will say my assertion is false. Assertion is false. And let's see the reason. The value of g, acceleration due to gravity, is less at Mount Everest. Of course, we have got the value of g is less at Mount Everest. So this is less. And as is where, so here we have region is true. So which option should we take here?
Option 3.
Option 3, A is not correct, but R is correct. That is option 3. Okay, so let's move to the next one. Assume that the Earth is solid sphere of uniform density and a tunnel is dug along its diameter throughout the Earth. It is found that when a particle is released in this tunnel, it executes a simple harmonic motion. The mass of the particle is 100 gram. The time period of motion of the particle will be. So what will be the time period of its motion? You have to take g on the surface of the Earth as 10 meter per second square. Radius of the Earth as 6400. Okay. So how to find out the time period of revolution? Time period here. So as we know that acceleration due to gravity, it varies with depth. The acceleration due to gravity g dash, it varies with depth as given as 1 minus d by r multiply g. So this is how the acceleration due to gravity varies. This is your acceleration, you can see. So we have here that acceleration is inversely proportional to the displacement. Acceleration is directly proportional to negative of displacement. It's 1 minus d by r. So displacement is d, and hence we observe that acceleration is proportional to negative of displacement. So it executes an SHM. Now how to find out the time period? Yes, which formula to be used for time period? Anyone, any ideas? Okay, in SHM, how do we go on finding the time period? Hello, hello. Uh, ये just ना निकल रहा है। ठीक बोले, ठीक बोले। हाँ,
Sir, you're on mute.
see, we have acceleration given by the formula. Acceleration equals to minus omega squared by. And if I want to find out the time period, see, this is our acceleration. This is our, this equation. Whenever you are supposed to find out time period, frequency, whatever for any SHM, so you should be using this formula. Acceleration given by minus omega squared y or minus omega squared x. Okay. If you are talking in terms of x, it will be x. If you are talking in terms of y, it will be y. So acceleration equals to minus omega squared y. This is how we will be using. Here we have got acceleration equals to r minus d or 1 minus d by r multiply g. Here our displacement. What is the displacement here? So we have to take our displacement common. The displacement means from the mean position. The displacement we take from the mean position. So it's something like this. I hope all of you are getting. Or do you want me to explain completely in detail? I expect you have done those chapters. Now I only need to do only questions only. If you are facing any problem, like if you do not know how acceleration due to gravity varies, you want that to be clarified or anything, so do report to me. Okay. Otherwise, it cannot be cleared if you do not ask. So here, this is the center of the earth. See, in SHM, all the displacements are taken from the center. Okay. So suppose the object is at a certain depth. So here, if the object is at a certain depth d, so the remaining distance or the displacement from the mean position is r minus d. Okay. So if I compare this, I can rearrange this equation g dash. I can make this equation g dash as g dash equals to r minus d multiplied with g by r. This is how I can rearrange this term. So this r minus d becomes my displacement, and hence if I compare, so here I get my omega squared should be equal to g by r. My omega squared should be equal to g by r. Are you getting? So since omega squared is given by, this is acceleration equals to minus omega squared y is the displacement. And if I compare both the equations, I get here y to be equal to r minus d. So omega squared must be equals to g by r. Okay. So I get my omega as G by R under root, and hence I can get this is omega is 2 pi by T, which is under root G by R. Now our time period will be 2 pi under root R by G. So by substituting the value, by substituting R, by substituting G, I can get the answer. Okay. And this answer, remember that we are using here SI system of units. Since acceleration due to gravity is measured in meter per second square. Okay. So putting the value, you can obtain the value of time period in second and then divide it to convert it to hour and minutes, whatever you are getting. So time period will be equal to 2 pi times of R, which is 6400 multiply 10 to the power 3 over G, that's 10. Okay. So you can get here 2, this 10 cancels, and you can write it as square root of 64 as 8. It will be 2 pi multiply 8 and multiply 10 to the power 2. So this is what seconds. And now you need to convert this second to minute divided by 60. You will get it in minute. And now I think you can tell the answer. So what should be the answer now? We have reached the answer. What answer should be there? You can multiply 6 pi. This is 2 pi multiply 8 multiply 10 to the power 2 divided over 60. So you will get your answer in minutes. Okay. So with 60, you will be able to get cancel one of the 0 and then obtain the answer. So which answer would be correct? Option 2 or option 3? After that, you need to convert your minutes into hours. So you will see this one. If you get convert, this is 60 plus 24, that is 84 minutes. Okay. And this is your 60 plus 40, that's 100 minutes. Okay. So what should be the time period here? If you roughly calculate this, 2 pi is 6 point something multiplied with 80. Okay. 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 So by all of you, I hope you have understood. Is there anything that you people have not understood?
Sir, could you give a brief revision of this chapter before doing questions?
Yeah, sure. We can do that. Okay. We can do, because I thought that gravitation, this is a very simple. Okay, so from the next class, we will be doing the briefing of the chapter first, and then we will start with the questions. Okay, I
Okay, sir.
think that way you will be performing better. And also, I'll be sharing all the questions of this chapter so that you can practice them also. Okay.
Okay, sir.
Okay, bye.
Thank you, sir.
Okay.